This is the video for Mod 7, Lesson 5, Medians and Altitudes for Triangles. The goals of this lesson are going to be to identify and apply properties of altitudes, to identify and apply properties of medians, and also to use properties of the centroid that's formed by medians to find segment lengths. The first topic we're going to look at are altitudes. So an altitude for a triangle is a segment that goes from the vertex to the opposite side. And when we say opposite, we mean the side that's across from the angle. And it is perpendicular, so it forms a right angle with that opposite side. In this first example, if it says BD is an altitude of angle ADC, one thing we know, if it's an altitude, again, it's forming a right angle. So we can actually say that DBC is a right angle. Or basically, we can say a couple of different things, like DB is perpendicular to AC, lots of things we can now say knowing it's an altitude, but basically it's forming a right angle with the opposite side. Every triangle, even though this one was the one I just did was a nice vertical line, every triangle actually has 3 different altitudes. So if we look at this diagram at the bottom, every vertex you could form an altitude with the opposite side. Sometimes the altitudes are inside this triangle, sometimes they fall outside the triangle, but they all intersect at one point, and we call it a point of concurrency, where they all intersect, and all the altitudes intersect at a point called the orthocenter. So if we have 3 altitudes intersecting, and for this diagram, C would actually be considered the orthocenter because that's where all the 3 altitudes intersect. An example of a question you could see on a test or a quiz might say, which of the following segments is an altitude? And they give you lots of different segments here. The outside of the triangle, those are the 3 sides that form the large triangle. That would be triangle ABC. So when they ask a question like this, we're really focusing on segments inside the triangle. So like you can see BX falls inside the triangle, BZ falls inside the triangle. And so when it's asking for which of these is the altitude, you're going to look for the one that forms the right angle, and that's actually going to be segment BX. So in this case, BX is an altitude, or is the altitude for that triangle. The other special segment we're going to see for triangles is a median. So a median is a segment that goes from the vertex of a triangle to the midpoint of the opposite side. So for this example, you can see, P is a vertex. It's not dropping a right angle like the one we just saw. It's actually going to the middle of the opposite side. So it's still related to the opposite side. It's just going to the midpoint, which means that it makes 2 segments that are congruent. So PN or NP can actually even be considered a segment bisector. So MN is going to be congruent to NO. For each triangle, actually, like altitudes, has 3 medians you can draw because there's 3 different vertices, and you're drawing it with the opposite side. So all of the medians always end up falling within the triangle because it's going to a midpoint. And 3 medians intersect at one point. It's called the point of concurrency, and we call that point the centroid. There's actually a special property with how this gets divided up. So the length of the median, like let's say AE, if I take 2/3 of that, that's actually going to give you AC. So there's like a 1/3, 2/3 relationship here that we're going to see in a moment. So what that means is if we know that the entire segment for a median was, let's say, 9, A to C would be 6, and C to E would be 3. Right? So it's actually a 1/3, 2/3 relationship, or a 2-to-1 relationship with the smaller segments. One example you might see is, which of the following segments in ABC is a median? So again, we have our triangle ABC. If we look at those segments on the inside, we actually have 2 different segments here. We're going to be looking for a median goes to a midpoint. So you can see we actually have 2 segments that are equal at the bottom here. So that actually means that BZ is actually our median. It goes to a midpoint. So BZ is the median. For question number 2, we're going to use the property of a centroid. And so if we look at this, it says CP is 30, which is this segment right here. What that property says is if I have a median, and I know P is the centroid, you can see they're all intersecting at P. If we look at this entire segment, make that in a slightly different color. If we look at that entire segment, CD is the long segment. So if I take 2/3 of that segment, of that big segment, that's going to give me CP. So the big segment, I'm taking a fraction of it to get the one piece of the segment. So when we go ahead and substitute this in, if I know CP is 30, and let's say I call CD maybe like X. If I want to solve for X, you can do a whole bunch of different things, but really we're just multiplying by the reciprocal. And so when I solve this out, CD, which again was the entire median, so that should be the longest length. If I multiply across, I get 90 over 2, or 45. So, and that's really CD. So this is actually 45. And then if I do 45 and this is 30, PD will be 15. All right, so that's one way to do it. Another thing you might notice, and I'm going to go ahead and redraw this triangle really big just so it's a little easier to see. And I'm going to take out all the other medians just so it's easy. You can see this from the vertex to the centroid was 30. From the centroid to the midpoint was 15. And you might notice that the relationship between 30 and 15, if I take 30 and divide it by 2, I get 15. That's actually another way you can do the same problem. So if I had the whole segment, you could do the 2/3. But if you didn't want to kind of substitute everything in, you're always going to have a 1-to-2 relationship as well. If you have questions, make sure you are trying the U-Try problems and then asking for help during class, signing up for T-Bolt time, or getting help in the center.